Good morning, everyone. Thank you for joining us today for another episode of OpenShift Coffee Break. Today we have our usual suspects in Natale as our main co-host and myself, the other main co-host. And we have two special guests today. We have Savita from Red Hat Engineering, and we also have Khurram. They both work on Tekton upstream community and OpenShift project. And OpenShift pipelines. Today they will be speaking about. Last time in the Tekton show, we covered the basics. We explained what Tekton was, the reason why it was created. In this episode, we are going to talk about how to trigger pipelines from a Git repository. So basically, whenever you make a code change, you do a Git commit or you create a pull request or something like that. You want to have some automated pipelines within your workflow. And basically, that's what we are going to uncover today. Savita and Khurram, if you want to please introduce yourselves. And of course, Natale also, but he's very famous already.
Yeah, I'm Khurram Baig, and I'm working on Tekton upstream project and downstream OpenShift pipelines. And I mainly focus on Tekton triggers, and I have also done some work on catalogs and on metrics as well as logging pipelines.
Okay, cool. Savita.
Hey, hi. So I'm Savita. So basically, I'm based out of India, Bangalore. So I'm also a developer who works on OpenShift pipelines and also Tekton projects. So I'm also a upstream contributor to triggers and catalog plumbing. So yeah, that's about me.
Cool. Thanks. Natale?
Yeah, thank you, everyone. Welcome. Good morning. I hope you had your coffee shot here at OpenShift Coffee Break. My name is Natale. I'm a product marketing manager with OpenShift, and we are hosting this show together with Jaafar. And we're very happy to have again Savita in the stream, and also to have a Khurram for today's talk. Jaafar, I'm really excited to see pipeline as code. So I'm looking forward to see what it is and how it can be implemented on top of OpenShift.
Okay, and so just one clarification for our viewers. We are making, as you saw, Savita was already on a previous episode. So our goal is to have a series. So we will be having several episodes about Tekton and OpenShift pipelines. And as we go along, we are going to explore more advanced concepts. So yeah, today we will be speaking about how to trigger pipelines from Git events, and especially explain what happens in the background, which is basically what you guys have implemented to make it work. That's the great thing. I believe you have contributed to creating the things inside Tekton upstream to make such things work, of course, with other people. So that's really cool to have engineers like you talk about how these things work in the background and how they evolve. So, okay, let's get started. Who wants to go first and maybe have a quick reminder about Tekton concepts?
Yeah, so I would go through first and then Savita will demo.
Okay.
Yeah. Let's share my slide.
Not yet. I think we also don't hear you very good when you speak, I think, no, Jaafar? There's some interruption.
Yeah, exactly. Yeah. So, Khurram, I'm sorry to say that, but will it be possible to maybe just disable the video stream to make sure we have enough bandwidth?
Oh, okay. So you're saying I should save some bandwidth?
Yeah. If you can just remove the video, now we can see the screen. It's fine. But if you can just like cut the video from the Zoom stream, that would be fine.
Oh, remove the video. Stop the video. Oh, sure.
You know,
Yeah.
Wi-Fi. You cannot trust Wi-Fi. Always plug an Ethernet cable.
Yeah, exactly. All right. So thank you, Khurram. We can see your screen now. The floor is yours.
Yeah. So previous time we had already discussed what is Tekton, and it's I think I'm not sure whether we have gone through various components of Tekton, which are the shared components to provide Kubernetes native CI/CD pipeline. First component is Tekton pipelines, which we have already covered, which is packaged as OpenShift pipeline along with triggers and operator. And then next we have Tekton triggers, which manages the Tekton resources based on events. And these events can be cloud events or webhook events like GitHub. And then we have something called Tekton dashboard, which provides a UI for handling Tekton sources. But in OpenShift, generally we don't use dashboard because we already have something called console or dev console. So we already have integrated Tekton components there. And then we have operator, which facilitate installation of these Tekton projects in an easy manner using operator lifecycle management. And we have also something called Tekton CLI, which provides a TKN tool to handle all these Tekton resources. And also we have something called Tekton Hub and Catalog, which provides reusable tasks and pipelines. So let's go to the Tekton triggers main concept. Basically, Tekton trigger provides some CRDs, which extends our Tekton architecture by expanding the Kubernetes. Some of these CRDs are trigger templates. Trigger template is just what pipelines and task run in a with some parameter in a parameterized form, and these parameters are based on events. And then we have something called trigger binding. And trigger binding CRD just extract those extract payload field to the corresponding variables which are referenced in the trigger template. And then next CRD is trigger CRD, which is just a combination of trigger template and trigger binding, so that we know from where to take our variables. And along with that, we have something called Interceptor. What Interceptor does is it just take payload fields and modify it.
Okay, thank you, Khurram. So if I try to demystify a little bit, maybe, do you have some more? Go ahead, please show me the next slide.
Oh, no. So I had just this one.
Okay. So let's pause for a second on these concepts and try to explain why we are talking about this. Okay. So usually when we are, as a developer, or even, if you are implementing continuous delivery, you want to trigger your pipelines from a Git event, like you make a commit or you merge a pull request or something like that. Then you want some pipelines to automatically get executed. So if we remember how Tekton works, you have this notion of pipeline. So basically, the pipeline is the definition of everything that is going to run, like the tasks and the steps, etc. But the pipeline itself doesn't run. It's not an instance of something that is running. It's just a static definition. Like if you were in Java, you have your class, and then you have the instances of your class. So the class doesn't exist in itself. Once you instantiate it, you have some objects. That's what has a real existence. So in Tekton concepts, the same thing happens with pipelines. It's the abstract thing. And then you have pipeline run, which is a running instance of your pipeline definition, correct? So what we missed was, okay, so I have my pipeline that is defined somewhere. And when I trigger or when I run, or sorry, when I have my Git event, I need something to create my pipeline run automatically, okay? And the pipeline run needs some information, like where is this Git repository? What branch is it? What is my working context? Etc., etc. So it needs some dynamic information because we don't want to have static information in the pipeline, static definition. So we have what we call placeholders or variables that we define in the pipeline. We say, for example, this is $git URL, this is $git branch, etc., etc. So this is all going to be variables. And at runtime, when we want to trigger the pipeline run, we want these things to be filled, right? We want to get the proper values. And that's, I believe, where those triggers come into play. So we have the pipeline, we have the pipeline run, and those triggers are going to say, okay, so when I have this Git event, please take this variable, and this variable, and fill that in the pipeline run, or to create a pipeline run, okay? So that's what I'm saying here is a shortcut. I have a pipeline on the left, I have a pipeline run with all the data that is already filled, and now we are trying to explain what happens in between, all right? So, so please go ahead again, Khurram, and explain maybe some of the additional concepts that, do this magic, like how we get the information of what Git repo we are in, etc. So we can go ahead.
Yeah. So if you have, I'm saying, if we have a webhook events from GitHub, generally it will be there in the payload, or maybe some information might be there in header, but generally we use payload field also, payload fields, and those payload fields are extracted to the parameter defined in trigger binding. Trigger binding, I would say it might have, let's say, 10 fields, like it might have commit ID, branch, as well as refs, but we need only commit ID, let's say. So we will, in our trigger binding, we will just have a field called commit ID variable, and it will be extracted to that. We will give proper body dot commit ID. Let's say it's in the commit ID position. So later on, it will be extracted to the trigger template, because in template you have specified that we need this commit ID. In the same variable form that was in the trigger binding. Yeah.
Okay. So I'm not sure everyone can hear fine because we have some audio issues. So that's why I'm rephrasing. So basically, what you just explained is we have something that says, here are the variables that are interesting to me. I want to get the URL, the Git URL, the branch, the etc., the committer ID maybe, or something like that. And those things, we define them in the trigger binding, correct? We say, these are the things that I want. And you have the trigger template that says, here's the data that you need to fill, like the Git repo, etc., are going to be variables. And basically the trigger bindings says, this is, you take this data from here and you put it here. Is that correct? So basically, that's why we call it a binding, because you say this data that is my variable actually comes from this information, which is somewhere else. Okay, cool.
Yeah,
thanks.
Trigger binding, exact location of the field is, I would say, exact location of the field is defined, where it is. Because in JSON, I would say it can be nested also. So you define proper nested field here in the trigger binding.
Okay, cool. Thanks. So I hope this is clear. For people who are watching, if something is not clear enough, please don't hesitate to ask questions in the chats. and we will try to answer them as we can.
Yeah. And then we have something called trigger CRD, which is a combination of trigger binding and trigger template.
Okay.
Yeah. And then optionally an interceptor. We have not discussed interceptor till now, but yeah, interceptor is just what I have said earlier, that it modifies your payload field.
Okay.
Or it can discontinue an operation, because let's say you have a push event, you wanted a pull event, something like that can be done via interceptor.
Okay.
And then we have an event listener CRD, which provides an event sync. Basically, all these operations like trigger binding and trigger template operations are done by event listener. It extracts parameter from trigger binding and creates resources for the corresponding trigger template. And
okay.
Yeah, or and you can also provide interceptor in the event listener to pre-process the event payload. And then we also have some advanced concept called cluster interceptor. Cluster interceptor provide a cluster scope in webhook style interceptor. Meaning you can have a K-native service which basically runs your business logic on the payload that is coming. It's just a K8 service actually, nothing else, and return a 200 response. We already have some like GitHub, Bitbucket, GitLab, and C common expression language CL interceptor already available. Cluster interceptor already available. So if you need, in addition to those interceptor or something, you can define your own using cluster interceptor.
Okay. So this is funny because it reminds me of so a few years ago I was trying to implement this kind of CI/CD with the GitHub actually, and they used to provide a bot. It was called Probot. Probot was basically this type of framework where you can define these things. You say, if I have a push event, then do this. But the do this thing is you basically have to write your own code to extract the information from the payload to do your own custom logic, and then it can interact with something else. So basically, I was implementing some Node.js backend that waits for something to happen on GitHub part, and that does something like, for instance, it can create a project in OpenShift, it can deploy an application automatically, etc. But all of that, you had to do it by coding things yourself. It was just an empty shell. And what you guys did here, I think, with the event listener, is you have implemented this feature out of the box. So basically, when you create your pipeline and you create your whatever you need to interact with the Git or GitLab, etc., you do instantiate your own backend that listens to these events and that already has all the logic to extract the correct information and to create whatever it needs to run the pipelines in OpenShift. Is that a correct way to phrase it?
Yeah. Even complex operation can be performed, like complex. I mean, let's say you want some. Let's say you have a pull event and you want, let's say, approve field or approve test, okay to test. Only then run your pipeline. All these things can be done by interceptors, CL interceptor, or combination of those. Yeah.
Okay.
Without coding.
That would be interesting, I think, for maybe a next show, where we can go a little bit deeper into interceptors and explain basically how we can use them to implement what you said, like approvals and such things, because I know that approvals are something that are still in the works upstream, like the structure to define how we can do that is still in the works. So that could be interesting for an upcoming show to explain how we can do those custom interceptors and integrate maybe with some external service or something like that.
Yeah, so basically one more point I just want to add here, like when we have trigger installed, right? So by default, we will have some 3-4 a core interceptor like GitHub, Bitbucket, GitLab, and CL, along with like as this cluster interceptor introduced, the main motive is to earlier with having this only like fixed interceptor was blocking the triggers to grow. I mean, it was not able to make use of the triggers in a dynamical way. So that's the main reason to introduce this cluster interceptor, so that user can, it's kind of a plug-in plug-out mechanism, like anyone can write their logic and they can plug into triggers and they can get the benefit of this eventing mechanism.
That's really cool. Yeah, so
Nice.
so if you have your own workflows that you have already automated in some way, like if you are doing, I don't know, Git flow or GitHub flow or things like that, where you automatically create projects or deploy applications, etc. That can be maybe a way to implement this type of behavior in a more dynamic way. So yeah, that's really interesting. And yeah, let's aim to have that dissected in another episode, because we like everything that can be automated.
Sure.
All right. Thanks a lot for the explanations. So this summarizes, I think, what you have said. Yeah, please go ahead.
Yeah, this summarizes what I've said. Let's say an event is coming to the event listener pod or sync, and then trigger binding is extracting those parameters and providing it to the trigger template. And we have some, I'm saying this is a combination of trigger, and then in turn it will create a Tekton resource. Okay, so Tekton resources are things like the pipeline run, etc. So basically, something that instantiates that's something that will run actually. Okay. Yeah. So okay, cool. There it's in the detail. Let's say you have done a git push, and you have some JSON payload, and it's going to the route of the event listener, and then it's then it's going to the trigger binding, which tells which okay, yeah. And so trigger binding basically have parameters, and then in turn these parameters are provided to the trigger template, which dynamically creates our Tekton sources. Okay. And so is that correct to say that the event listener is an application itself that runs in a pod, like it's something that is it's an event-based architecture where you have a pod that listens for something to happen, and when it intercepts that event, it does something. Is that correct? Yeah, it's correct. Okay. That's why we also call it sync. Actually, internally, it's called sync. Okay. All right. And so is it that pod that creates the trigger binding, etc., or how does that happen? What does create those things? Like, I mean, what fills the information? Is it the event listener itself? I didn't get. What is the question exactly? Yeah, sorry. So what does the event listener do exactly? Like, you have an application, and it intercepts the events, and then it extracts the data from the payload. Is that correct? Yeah. It extracts those data from the payload and applies to the trigger binding values. Okay. Basically, if I would say, and discard all other values which are not needed. Okay. Yeah.
So basically, it's a KTS pod. I mean, like when we create an event listener custom resource, right? So it internally creates a one pod which keep on running, and also creates a service, so that that's the reason we will get the URL in the event listener, so that we can use that URL and send the event. So whenever event comes, that so before that only someone has to apply this trigger binding and trigger template. These are like a static templates, we can say. So
okay.
Whenever an event comes to event listener pod, so then actions happen. So then the actual work will happen, like trigger binding will fetch those dynamic value and pass it to the template. and the template internally creates the pipeline run and task run. I mean, Tekton resources.
Okay. Yeah. Thank you very, very much for reminding this point, because it's very important. The URL actually is what we put in the webhook definition, correct? In the Git repo side.
Exactly.
So you say, I have a webhook, and you select whatever events you want to intercept, and you put that URL that is generated by the OpenShift router, basically, to point to the event listener for the specific repository.
Just as sorry, just as confirmation, the event is an HTTP post from a webhook, right? It's always HTTP, HTTPS. It's a post with a JSON content or any other form. So this is the kind of event which is this component is listening to. And I have a question. I don't know if you are aware for the next version of OpenShift, if there will be an improvement in the pipeline UI. You know, now pipeline UI helps you creating at ease a pipeline in OpenShift Web Console. Do you know if that will be easy also to create the trigger part? You know, you have to write your trigger template, your trigger binding. I was wondering if there's gonna be any UI help on creating triggers, also this part.
Yeah, so maybe like more thing we will see in the demo section. So right now, like OpenShift, OpenShift UI have basic template for the triggers, and which will just give us the end-to-end flow. But coming to the advanced use cases, so right now it's under still implementation. But yeah, to answer your questions, right now UI supports the trigger adding part along with the pipeline creation.
So if I'm not mistaken, that's what you mentioned about like the pre-existing stuff for GitHub and GitLab, etc. Because you can already say, I want to intercept this event from GitLab or whatever, and it will create those event listeners, etc., with the correct information.
Yep, exactly.
Yeah, because if you have to create everything via YAML, it's a bit complex.
and so manual work.
So since we are speaking about both Tekton and OpenShift pipelines, and we are rightfully, you know, we have a foot in community and we have a foot in products. So does these things, can they also be done from the upstream UI, or is it something that we add in the OpenShift console as an added value? Like I haven't played with the Tekton dashboard. I don't know what the UI does. So
it's a dashboard UI and dev console UI are completely different, and they're also following different architecture actually. So
okay, but these things that Natale mentioned, like creating the event listeners automatically from the UI, etc. Is it something that we can also do upstream, or is it just in OpenShift pipelines that we have this added value?
Oh, I also haven't used upstream.
I can just tell my experience, like in upstream dashboard, like dashboard, what we need to paste the YAML files. I mean, there is no direct form creation. I mean, with few inputs, we cannot create all these resources, but instead of like, we need to paste the entire YAML. But in case of Open, of Open UI, everything is automated, most of the things.
Okay, cool. So so that's part, I would say. So that was a very, you know, genuine question. I didn't know what the answer was, but so this is basically something that we do as part of the added value of the OpenShift console, where we make it even easier to use upstream features, but in a more productized way. So I think we have things like also designing the pipeline. Maybe you will show something like that during the demo, where we can just show the screen. Okay, but yeah, thanks for the information. All right, so it's 10:30. I don't know how much time Okay, so let's go ahead and have some concrete visualization of those concepts.
Yeah, so here we have our triggers event listener CRD. So we have just a kind event listener as well as service account, which is used for creating resources. And we have some trigger reference trigger. That's the name of trigger here. And then we have trigger binding CRD. And we can see here exactly the kind trigger binding. And the next thing that you need to notice is params, name git revision, and we have a specified body dot head dot commit ID. It means let's say this is a position where commit ID is available in the GitHub, and similarly Git repository audit. Bodies by body means your payload. If it is header, then you have header dot something. So body dot repository dot URL.
Yeah. So sorry, just to make sure I understand it correctly. In your payload, when you have your Git event, it has something called commit ID, and it has something called repository.url, okay, in your JSON payload. And basically what this says, this trigger binding says, extract this thing that you have in value and store it as Git revision. Is that correct? Like this is going to be the parameter name, Git revision, that would be used somewhere else?
Yeah.
Okay.
Git revision, Git repository,
Okay. Yes.
And I guess this JSON, you are kind of navigating the DOM of the JSON, not from the webhook post HTTP request, and I guess those fields here change, no? If you're using GitHub or Git or Gox or GitLab. So yeah, from the experience, I think they're pretty the same, but sometimes they change. So if you wanna, say something about it.
So all this, so by default, we provide in OpenShift, the pipelines we provide some trigger binding like GitLab, GitHub, and I'm not sure. I think Bitbucket also we are providing, and all those values are unique to their own. I would say
and so a funny thing that you mentioned this, Natale, because for many reasons. So at some point, many years ago, I think it was 8 years ago or maybe 10 years ago, there was a group of software vendors that said, okay, so whenever I have an issue like a Jira issue, if it's in Jira, it's something. If it's in GitHub, it's something else. If it's in GitLab, it's something else. Can we come up with some sort of standard to make things to be able to integrate? Like, can we define pivot formats that any integration tool can attach to, and then every tool fills this information. And there was a standard that started to be defined called OSLC. I think it was Open Services Lifecycle something. I don't remember exactly, but basically, it's exactly what you are pointing to. Like, so when I have a payload from Git, it's going to be a different JSON. When I have a payload from GitLab, it's going to be another different JSON. So thus you have a specific implementation for every tool. And the goal of this thing was to have one standard pivot format that you integrate with. So it's always going to be head underscore commit underscore ID. And whatever you have on the other front, like if it's Git, it's going to be transformed to fit in that field. So you don't have to implement it for every different tool. So I'd be, I'd be curious to see where these things are, and if it would make sense, even upstream, to start to define something like this is the standard that we want for an issue, and then GitLab fills it, and GitHub fills it, and etc. etc. So maybe that's a conversation that can happen upstream to see, if there's a way to. It's basically the same thing that happens for Tekton, right? So before, every IT vendor has its own definition of pipeline and what a step is and what the task is, etc. And it was not compatible. But now with the Continuous Delivery Foundation, they said, okay, let's define some standards and let's create these Kubernetes resources, which are a pipeline or a task or a step. And now every tool that implements Tekton uses the same standard, right? We don't have anymore each one with his own definition or his own DSL to define a pipeline, like the Groovy for Jenkins and the YAML for GitLab runners, etc. So now, if we are using the Tekton part of it, it's going to be the same YAML. It's going to be standard things. So maybe it can make sense to go even further and say, okay, now let's standardize on those bits as well. So we have one common payload that is filled by the different tools in the same way.
Yeah, so I'm saying, so there was a discussion regarding this having trigger binding in catalog. So what will happen is we will already get trigger binding for GitLab, GitHub and Bitbucket. All those will already have, and we already have a parent defined, and value will be provided by upstream. So I'm saying we can just use in trigger template the same value, whether it is GitLab or GitHub.
Yeah, okay.
Value will already be provided by catalog.
All right. All right. So yeah, just closing the parentheses here, but Natale, this was a project that I had in mind for a long time, to have this, this unique pivot standards. And I even wanted to do it like with camel transformations, where you have, the standard listener, and then you do some transformation to generate the correct payload that we expect. So you intercept the GitHub payload and then you transform it, and you generate one standard output that will be, always the same thing in here. But,
and you see, you have it here as open source upstream project. We have today awesome engineer talking about it, which is very, very cool. And you know what? This is another example of Kubernetes, which is a standardization also platform. We're going everyone into the same standard, same open source, same project, same standard. So this kind of, converging on the same thing, which is very cool. I think we can go in the next step, because we're going otherwise out of time. There is also some interaction in the chat. Some people would like to know more about Tekton. Yeah, we will share after this live demo some resources to get started with Tekton, and also if you have any useful links, Savita, and please share with us so everyone can start learning Tekton.
So here we have defined some trigger template. You can see some params that are available from trigger binding. Let's say Git revision, Git repository URL, message, content type, and in the resource template we are using it like tt.params.message, tt.params.content type. Okay, and then we have something called cluster interceptor. That we won't go into detail, but just what it does is it modifies the payload. That's what already said, and this is how we define. Let's say you have a service, it creates service, a deployment pod running, which modifies it and give it 200 response. So what you have is name of the deployment, namespace, and path, where you have to.
So for another episode, I don't know when, let's try to have this. Let's try to implement a custom interceptor that integrates with ServiceNow to do an approval, for instance. Let's have that as a background idea.
That's interesting.
All right, thanks, Khurram. Yeah, go ahead, please.
And we have Yeah, so advanced features also like some label selector. This feature, because some customer are requesting that in every image they have to have a listener. If it's multi-tenant OpenShift install, what they wanted to single email so that there is less resource consumption. So we have this image. Then we have Tekton trigger end-to-end TLS connection. I mean, from pods to router also we have TLS support. That's because this was also a customer. And then I'm native for event listener so that it's
sorry, Khurram, we have
audio issue.
We have audio issues. It's dropping a lot. So please excuse me if I rephrase what you said. Well, basically, people who are watching can read this. The most important or interesting thing I see here is the serverless thing. Is it correct to say so? Savita, please confirm.
Yeah.
So when we spoke about the event listener, we said there's a pod that is always running to intercept whatever things. So that's cool. But I'm imagining if we have hundreds of integration like webhooks. So that means we have hundreds of pods that are running, but they are just waiting for something to happen, and they are consuming resources. What I understand now is this can be serverless also. Like we can have something that doesn't exist, like no pods, but just a URL. And once we have the webhook, it actually creates the pod. It does its thing, and then it shuts down. It shuts down. I still have to work on my English. Okay, so that's very cool. That's very cool because now we are saving resources, but we still have the eventing side of things.
Yep. So,
Okay,
so
cool.
basically, like till now, event listener, whenever we create, it used to create K8s pod, right? So now, like we integrated with Knative service. So with the help of Knative service, we could able to achieve this serverless thing. So so there is another we have a custom resources in event listener. Like we can specify Kubernetes resource or custom resource. So basically, this custom resource can be Knative, or it can be any other thing which can be integrated with event listener. So along with Kubernetes pod and Knative service, if something, if user wants to run, they can implement their own CRD and then integrate with event listener.
Okay, that's cool. So so they can create their own operator to do something and then integrate with it.
Exactly.
That's cool. Yeah, so we are going a bit short of time. Do we want to jump in the demo, or I don't know how much time you want for your demo, Savita?
Yeah, I think it would be better if we jump to demo so that like we can see all those things in action. Yeah.
Sure.
Yay,
Let's go. Let's go ahead. Thank you very much, Khurram. It was very interesting, and it lays the ground for the future episodes. Thanks a lot.
Yeah, thank you, Khurram. You made my life easier now for the demo. So I'll share my screen. I hope it's visible.
Yes, it's fine.
Okay.
Just please, if you can increase the font so we can see better in your demo.
Sure. Yeah. I see something. Click is not working in my mouse. Okay. Yeah. Fine. Yeah. Okay. So yeah. So for time being, I just installed everything like Tekton OpenShift pipelines using operator. So oh, I don't know why it's okay. Give me a second. Sorry for the interrupt.
Yeah,
No
no
problem.
worries, no worries. So
Yeah.
maybe
Okay.
it's fine.
Yeah, it's fine now. Okay. Yeah. So yeah, for okay. So everything is installed in this cluster. So all the OpenShift pipelines and all. So the one thing to make sure that the OpenShift pipeline is installed or not. So we can see a pipeline column here. So
Section.
pipeline trigger. So it shows like, okay, this cluster has pipeline installed. So now, like without wasting time, I'll just go and create a pipeline initially, and then I will add a trigger to the existing pipeline to show like how we can add trigger to the pipeline and and create a pipeline run based on the events.
Okay.
So okay, let me create a new namespace called demo. So project. So yep. So yeah, so project got created. So
Yeah.
I'm going to use this form git so that I can specify my own GitHub repo. So this is the one which I have created for this demo. So by default, it selects the builder as Go. And I'm not going to touch any of the things. So just I will add a pipeline. So what it will do while creating this form. So if I click this button, add pipeline, so it will create a pipeline template for me. I no need to
Okay.
create pipeline template manually. So instead of that, this OpenShift pipeline operator has integrated all these things. So this is the functionality of the OpenShift pipeline operator.
Okay.
When I create this thing, so a pipeline will be created. So yeah, so let me go back to this pipeline section. So I'll select the project which I have created. So you can see a pipeline is getting creating. So
Okay.
now,
And it's
like if
already
I,
running.
yeah, so because in this dev console, what we have done as part of the UI, in order to make our application or like my task, my pipeline is working or not to from the GitHub. So what we have done, like initially when user create for the first time, we are triggering the pipeline run also automatically. But later, when we do some edit to this pipeline, okay, so okay, before that I just want to show like pipeline run is triggered already, and just for the refresh purpose, like this pipeline run contains 3 tasks: fetch, repository, building and deploying. And all these 3 tasks have several steps, so those steps will actually run the containers and do the operation. So now like how to move this one, I want to edit.
Yeah, and go back to the pipeline.
Yeah, okay. So here, like if I go to pipeline, I will have a edit option, right? So here
Yeah.
edit pipeline is there. So if I do some edit operation, I mean I can add some task or edit something. So once I do this edit operation, after that, to get changes of those edit things, I need to rerun here. I mean I need to start it again, but I don't want to do that start manually, right? So as you
Yeah.
explain, as we discussed in the present while presenting, like we don't want to start any of the pipeline manually. Instead, whenever a event occurs, it should rerun, right? So based on the events. So to do that, like we have a trigger concept as we discussed. So till now we just created a sample pipeline and pipeline run automatically. But later on, whenever there is some changes to my repo, so basically my repo is this one. This is the one which I have given while creating the pipeline template, right? So whenever
Okay.
there is some action happens here to this GitHub repo, it should automatically trigger the pipeline run for me. So to
Okay.
do that, earlier there was no add trigger form here, but
Oh,
now
nice.
recently we have added this add trigger. And here we have the option to select like which provider we want, like whether it is a Bitbucket, GitHub or GitLab. So basically we have supported all these things, and it will be inbuilt added to this operator, so that by default all these things will be created already, so that we can make use of them directly. So
Nice.
for yeah, so for my use case, what I will do, I will make use of this Git pull request. So I'll use this Git pull request, which is a trigger binding. Okay, and by default it will take this app name, which Git repo, from which branch, and what is the image name. So everything will be taken by this UI itself. So now my job is just select this provider type and click on the add button. So now
that's really awesome, because otherwise it would take too much work to create all the YAML stuff. Yeah, like
exactly.
figure out the JSON payload. How does GitHub store the pull request in the JSON, etc. So very cool.
Yeah, exactly. So now, like, once I have added the triggers to see like those resources got created or not, again I can go back to administrator view, and here I can choose trigger tab. So you can see a event listener got created just now. You can see time also. And one thing I want to show, like, I have not created I have not created any trigger bindings, but OpenShift pipeline operator by default it have all these cluster trigger binding. So it's available at the cluster level. So that so basically in triggers we have two CRD called trigger binding and cluster trigger binding. So all these things are shipped as a cluster trigger binding because everyone can use it across the cluster. And if someone want at the namespace level, they can directly come and create in the trigger binding using this like YAML way. And also we can see a trigger template. So before that, in the cluster trigger binding, I just want to show how this GitHub pull request look like. So if you see YAML here, yeah, so we can see these are the different parameters it's actually watching, I mean from the webhook. So
that's
URL
very nice.
and revision, action, pull request number, and full name, and everything, like whichever the required information. And same thing will be used inside trigger template. So I'll go back to trigger template now. So we can see here in the YAML section, see, we use all those parameters from the trigger binding. And in the spec, like we are making use of the from which repo and what is the name and all. And we are finally using the pipeline which we created initially. We are not creating any new pipeline here. Instead, we are just making use of the already existing pipeline, because we did add trigger from the existing pipeline, right? So it automatically created this trigger template and added this resource template of kind pipeline run. And while adding kind pipeline, it referred the pipeline which is already existed. So now, yeah.
So now I believe we are going to add a webhook to the Git repo, right?
Yes. So before that, one more thing I just quickly want to show this event listener, how it looks like. So this is how event listener looks like, where we have a triggers and template binding things. I mean, these things club together so that information can be shared. So now, like as I have created everything, so this event listener internally creates a K8s pod as we discussed. So it will create a Kubernetes pod. So and it keep on running as it's a Kubernetes based. So it keep on watching on the event. So it's like continuously running, and it just watches on this port. And another thing is, like, when we create this one, it automatically creates a route also. Oh, okay. There is some error from the UI side.
Yeah, just refresh the console and see if it works.
Okay, sure.
This is 4.8, right?
Yes, 4.8.
Okay. So yeah, it should be some.
Okay,
yeah.
cool.
So,
all right.
Yeah. So now, like, yeah, sorry.
Let's copy that, I think.
Yeah. So when I click this URL directly, I'll straight. Okay, sorry. Yeah. So I will get the error because I have not passed any information, right? I should pass the proper body format. Otherwise, my event listener should straight away reject the information. So that's why it gave the error. Now I will make use of this URL and I'll go back to my repo, right? So this is the simple Go app which I use for the creating pipeline. I will go to settings and add it to the webhook. So here is the webhook. So I have already set it up for testing purpose. So I will just straight away clear everything. So here we will specify the payload URL of our event listener one, right? And
Okay.
content type always should be application JSON. This is the one which it will expect. And then we can select anything which we want. So right now I'm interested in pull request, right? So I just click on this one. Let me individually select. So I just selected the pull request. So in pull request, we have these many events. I mean, these many information, like whenever there is a PR open, close, reopen, assigned, unassigned, anything happened on the pull request, event should send to my pipeline. So I will just update this webhook. Yep. So webhook is updated. So I have already created few PRs for the testing purpose. So what I will do, this is the existing PR, right? So I can do any action on this pull request. So if I do some action, it should automatically re-trigger for me. So before doing anything, I will just go back here and show, like, currently we have only one pipeline running in this demo namespace, you can see. So now I will just close this pull request, right? After this, if I go and see, a new pipeline run is up and running, because a event comes to this event listener, and then it recognizes that pull request, and it fetches all the information from the trigger, information to trigger binding and given to the trigger template, and finally it created the pod for me, I mean this pipeline run from the trigger templates. So if I go back here, this is the one I was saying. So in the trigger template, we have specified a pipeline run. So yeah, so you can see here we have specified a pipeline run. So this pipeline run is executing the pipeline, which is
Very
referring
nice.
to the original one.
Cool.
Yeah, so that's really cool, and we see that it works very fine. So great to see that working live. I have a question on the pipeline run. Can
Yep.
you please go back to the UI? Yeah, okay.
Yes, yes.
Pipeline run. Can you click on it, like on the pipeline run there?
Yeah, sure.
Is
So
there
you-
something on the metadata? Okay, trigger event ID. So say now I want to understand what has triggered the execution of my pipeline. Like there was a commit ID, or there was a pull request ID, or whatever. Is this stored somewhere in the metadata for the pipeline run, or not for the moment?
So
Like
Every event that comes is assigned an event ID actually by event list. Every event that comes from GitHub or GitLab is assigned an event ID, and then label called by. So where it is given an event ID. Let's say right here, go there Tekton triggers dot
sorry, Khurram,
event ID.
but we have audio issues. We couldn't understand.
so
Savita?
basically, yeah, basically he's trying to say, like, each pipeline run, whatever we trigger, it has a unique event ID. And also,
Okay.
like, in the pipeline run, we can see triggered by who. I mean, like, who has triggered this pipeline run.
Okay.
So this information
Which is
gives
important.
us, yeah.
Yeah.
So
And if we go to the event listener,
Savita, can you go to the labels? Last labels will have more in the labels.
yeah,
Same labels.
this one.
So they full event ID. It's not. Yeah.
okay. Yeah, so maybe that's something we can talk about offline, but what would be very, very cool is to be able to trace from the pipeline execution what has started from the Git repo. So like if it's a PR, I click on the pipeline run and I have a direct link to the PR to understand what code has been merged and these things. That could be really nice. I think it's very easy because it's already in the metadata from the pull request. All we have to do maybe is to add a label, as Khurram said, that links to the URL of the PR.
Yeah,
that would be really nice.
Yeah, that's a good point. Like yeah, we can keep on add and increase these things. Yeah, your feedback is very valuable. We can consider this one.
All right. So that's why we bring your engineers here, so so we can also have this type of exchanges with even if people are asking some questions. So thank you very much. I believe we are already past the hour. So
yeah, we are a little bit out of time, in OpenShift TV in the morning, in mornings is pretty clean, free, so we can go extra time, a bunch of minutes, so we have time, Jaafar, to wrap up everything. The only thing I put in the chat is the link to our learning portal, because someone asked how to start learning about Tekton. Also, we have a scenario where you can start learning about OpenShift pipeline on OpenShift. Then, if you like to, we have the Tekton deep dives, a series of all online events when an instructor will do a deep dive on Tekton. And the material for learning Tekton is the other one I put also in the chat. So those are two valuable assets that Red Hat developers offer to start learning OpenShift pipeline and Tekton on top of OpenShift and Kubernetes. Just wanted to share our resources. I don't know if you folks have additional material we can share with the people to start learning Tekton and all the things we have seen today.
Maybe like we can add all these links in the YouTube link so that people can directly refer from there. It would be great.
Yeah,
we can just add over there.
Very good. Yeah, very good idea. Okay, so thank you very much again to everyone. Savita, Khurram, it was a great session.
Awesome.
Thanks, Natale, for being always such an awesome host and asking great questions. So in the next sessions, I hope we will be able to cover these things that we discussed, like maybe this suggestion how to trace back to code. If it comes in one of the upcoming sprints, I will speak about it also with Samak.
Well, I have a suggestion, Jaafar. Our next show, this is this show. Our show is bi-weekly on Wednesday. The next one would be August the 11th. If we want to do another Tekton episode, we can use this show. We can try to prepare something, but we will see each other on August the 11th.
11th.
Yeah.
Perfect. And so I was gonna say, so again, as a wrap up, thanks a lot. We already have good topics to cover for the upcoming sessions. We will see for August 11th. Maybe we can speak about the new feature called pipeline as code, really, like where we embed a Tekton in the Git repository, and then we automatically trigger that based on those events. So that's another further step. But we first wanted to show this thing before, because this thing runs now. The pipeline as code is in dev preview, but we will speak about it definitely. And I'm very interested into custom interceptor thing, because I like to tweak things.
Me too.
And I have some very good ideas. The custom interceptor can do what we said. It can pull the data from the pull request, and it can add a label to the pipeline run to have the URL. So that's a very simple use case we can do already. And then we can see integration with ServiceNow or whatever. So thanks a lot. Thanks again. Thank you very much. Thanks for everyone who connected on the stream. Thank you very much, Natale, for setting this up and making sure that everything runs smoothly. And thank you, of course, Savita and Khurram. And we hope to have you next in other episodes. And I wish everyone a great day. And we are going to end the session now. Thanks, and see you on August 11 then.
Thank you.
Bye-bye.
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 Thanks, everyone. Bye-bye.